Hello, this is Mr. Collier, and today we're looking at Voronoi diagrams. Okay, they come up a lot in real life and city planning, and they also come up in nature. So let's take a look at this coordinate map of these sites A, B, C, D, which represent fire stations in a city map. Okay. So these are 4 different fire stations. Which fire station is closest to 6, 3? Well, that's over here. So that would be fire station C. So that would be the best place to send a fire truck from, would be from fire station C, right? And any point over here, and here, they're closest to C. And yeah, so there's lots of places that are closest to C, obviously. Let's look at the next one here. 4, 6 is up here, and this looks like it's a bit closer to B. Okay, so how do we tell in general how close a point is to site B? Well, it looks like the midpoint between A and B is right here. You can use the midpoint formula, of course, but you can easily see that's the midpoint, right? So any point over here will be closest to A. Any point over here will be closest to B. And let's look at another point. Like this point right here. That's an equal distance from A and B. So if you draw the line, let me just erase a couple things here. If you draw the line through here, this is the set of all points that are exactly equal distance from A and B. Okay, and then we separate it. We basically separate the graph into 2 regions, one that's closest to A and one that's closest to B. So you can see if there's a fire in the green region, you should get a fire truck from B. If it's in the blue region, it should come from A, right? So that's what a Voronoi diagram is all about. And this red line, it goes to the midpoint. Okay, let me draw this line here. It goes to the midpoint, and it's actually perpendicular to this line AB. So that's a perpendicular bisector. Perpendicular bisector. So perpendicular bisectors split it into regions like this. So we need to find perpendicular bisectors. Let's erase this green stuff here. Let's redraw that. So the perpendicular bisector goes like this, right? Now if you look between A and D, the midpoint is right there, and this is vertical, so if we draw a horizontal line, that's a perpendicular bisector. Okay, let's try to draw it a bit straighter. Between D and C, the perpendicular bisector goes like that. So things over here are closer to D, and points over here are closer to C. Alright, and now between B and C, you need to find the midpoint. It's right there, or you could use the midpoint formula. Now the slope here is -3/1. So the perpendicular bisector is 1/3. So this is the perpendicular bisector. Okay? All points on the blue line are equidistant from B and C. And we can extend these lines a bit until they meet. Erase that a bit. This should be a bit straighter. You also need a perpendicular bisector between A and C. Okay, the midpoint between A and C is right there. Actually, I'm going to use black. Slope here is -2/3, so we go 3/2 is the negative reciprocal of that, right? Okay, so this line here separates the A and the C. And I think the Voronoi diagram looks something like this. Okay, so we got it split up into 4 regions. And these regions are called cell. So this kind of works with cell phones too. That's why they're called cell phones. You have cell phone towers, and anytime you're in this region, you're closest to this cell phone tower, and anytime you're in this region, closest to this cell phone tower. So these are called cells, and that's where the word cell comes from in cell phones. Okay. Okay, this is the guy who invented it. Some guy named Voronoi with a Y, but the Voronoi diagrams with an I for some reason. Here's the completed Voronoi diagram that we just did. Here's some vocabulary. Sites are the points A, B, C, D, E. Cells, we just talked about, those are the regions. Edges are kind of obvious. This is an edge. And the vertex are points where the edges meet. Okay, so that's some vocabulary that we're going to use. Okay, in this example here, how many cells does this diagram have? Well, it's got 4 regions, so that's 4 cells. How many vertices? We have 1, 2, 3. These are these points where the edges meet. And identify the sites closest to 2, 3. So 2, -3 is there, so that's closest to B because it's in this cell. And 1, 5 is in the A cell. -2, okay, this one is between C and D. Okay, what can we say about all the points which lie on the green line? Well, they're all equidistant. It is an equal distance from A and B. Okay, there's some more examples here, but let me show you some real-life examples. When cells actually grow, like cells in the body and stuff grow, they often make Voronoi diagram type shapes. So bubbles might make that kind of shape. Things that grow, like plants, patterns on animals can grow like that because when this giraffe is in the womb, it's just a bunch of cells that are growing, and the pigment cells are growing, and then they just kind of like meet up with each other, and they make these Voronoi diagram type patterns. Okay, so that's a quick introduction about Voronoi diagrams. They have a lot more applications, but this was just a quick introduction of how it works, how to draw one, and some vocabulary terms related to it.